Okay, so let's start off with solving another inequality. Now remember that inequalities are just like equations, so everything we learnt about equations uh, holds true. So again, let's solve, then graph, state in interval, and set builder notation. All right, so example 1. So let's say we had the following problem. Um, minus 6x plus 2 less than minus 9x plus 3x minus 1. Right? 9x minus 9x plus x minus 1. So let's go ahead and solve this just like an equation. Don't pay too much attention to the inequality. It will do its thing. So distribute here, minus 6x minus 12. Now we don't have to change the sign here because we didn't multiply across. We just multiplied on the left side, so that doesn't change the sign. Plus 3x minus 3. Let's simplify first on the two sides. So over there, that's also going to be a minus 6x minus 3. And let's get the x's to one side, and my preference is of course to bring the x's to the left side. And we have the x's canceling. Oh my goodness, so the x is cancelled, right? So no variables. True statement though, true statement. So just like when solving equations, no variables but a true statement. What does this mean? This means all real numbers, all real numbers. So how would you graph all real numbers? Well, it's the whole line. So really, it's impossible to have a beginning or an end of it. So there it is. Now what would the interval notation on this look like? Well, it starts at minus infinity and ends at positive infinity, like so. And what would the set builder notation look like? Well, it would be, in this case we're using variables, x, so it'll be x such that all real numbers. Okay. All right, let's take a look at another problem, another example. um, and so let's see. I want to get one with fractions in it. We can review that as well. So example, 1/3 x minus 7/9 less than 5/9 x plus 1. So what do we do when we have fractions and equations? You multiply by the LCD. So you're going to multiply by the LCD to cancel out those fractions. So the LCD in our problem is 9. So I'm going to multiply everybody by 9. So 9 times 1/3 x minus 9 times 7/9 less than or equal to 9 times 5/9 x plus 9 times 1. So this is over 1, over 1, over 1. So this is 9/3 x minus 63 over 9. This is 45 over 9 plus 9. And these, if we did this right, all the fractions should cancel. So this is 3x minus 7 less than 5x plus 9. So again, let's get the x's to all to the left side. So minus 5x, that's a minus 2x, minus 7 Right. Now some of you may prefer to take the x's to the positive side, meaning you could have subtracted the 3x from both sides and kept things positive, which is fine with me. Just remember that you've changed the direction, that you have to be consistent about which end is open when you do the inequality sign. So now I'm going to add 7. So I get minus 2x is less than 16. And so divide by a negative 2. Now be careful. So we are going to divide by a negative, and so that means that symbol changes immediately. And so we have x greater than negative 8. So if you were to graph this, here is negative 8, greater, so greater is to the right. And so in interval notation, this would be negative 8 to positive infinity, parentheses on both. And in set builder notation, this is x such that x is greater than negative 8. Alright, so those are some basic inequality examples. But now let's take a look at some compound inequality examples. Compound inequality. Now, compound inequalities are inequalities that have multiple things to them. So, for example, this is in a compound inequality: minus 7 less than p minus 6 less than or equal to minus 5. So, sort of an example of a compound inequality. Now, this is really no harder than the other inequalities. You want to solve this. You want to get the p by itself. Now, to get the p by itself, if you focus on the p part, then you're going to add 6. But here's the thing. When you add 6 to the middle there, you're going to add 6 to the right, and you're going to add 6 to the left. So in other words, you're going to do everything to the left and the right. It's that simple. Don't break it up as 2 or anything like that. Just use the one inequality, add to all sides, like you see. And then that takes me to minus 1 less than p less than or equal to negative 5. And you're done. That's the answer. That's the answer, right? That's simple. So we can graph this. So here's the graph. Okay, to practice all 3 forms of writing this. Here is minus 1. Here is oh, that should be a 1 plus 1. Minus 5 plus 6 is 1. Okay, here is plus 1, and let's say that's a closed circle right there. This is an open circle right here, and p is in between those, so it's right there. And in interval notation, this would be minus 1 1 parentheses bracket, and in set builder notation, this would be p line the answer, like so. There it is. Let's do another one of those. Let's do one with a fraction to it. So 3/5 less than negative x minus 5 over 3 less than 2. And just like we did with the previous problem with a fraction, we can clear the fraction by multiplying by the LCD. So the LCD for this problem is 15, if you look at all the denominators. So I'm going to multiply through by 15. So I got a 15 there, a 15 here, and a 15 here. And then I'm going to write in the problem. So it's 3/5, and then here, careful, minus x minus 5 over 3. And then over here is 2. So 3 times 15 is 45 over 5. And on this one here, we would have, we can reduce these fractions right there. It make our life a little easier. And then distribute. So we would have minus 5x minus 25 less than 30. And then on this one, it'll be 15 if I divide those. And I get 15 less than minus 5x minus 25 less than 30. So to get the x, I'm going to now add 25. to all sides. So that's going to give me 40 on the left minus 5x less than 55 on the right. Now here's the thing. I'm going to divide by a negative 5. Now the moment I divide by a negative 5, everybody, first of all sides, there is the negative 5. All these symbols are going to change. Not equal to, just greater. All these symbols are going to change. So over here on the left, I get a negative 8, new symbol, x, new symbol, negative 11. Okay, and there is my answer. So again, if you don't like the way this inequality is written, you can always change it around, making sure the pointy end is pointing to the stuff consistently to the same stuff. So in other words, this is the same as saying minus 11 is less than x. Notice the pointy end is at the 11, the open end is at the x, and then the pointy end is at the x, and the open end is at the minus 8. So this is your answer right there. And so if I would draw a graph of this, here is minus 11, here is minus 8, open circle, shaded in. And in interval notation, that would be minus 11, minus 8. And in set builder notation, that would be x, line, and your answer. Alright, so that's it for this video. On the next one, we'll explore and or inequalities.